Hello, my name is Darby Blackstone. I'm a Facilities Mechanical Systems Technician here at Ohio State University, and today we will be talking about belt tensioning. Before we get started with our procedure today, we need to talk a little bit about safety. First of all, you should always de-energize the equipment you're working on and use the lockout tagout. And you should also always wear your safety glasses and any other protective equipment you might need. Now that the equipment's de-energized, we can get a closer look at the belt, because though it may look good on the outside, you can clearly see that it's been cracked on the inside, and any cracks in the belt will only get worse and can damage the equipment very badly. Another important part of the belt drive is the sheave. Though the sheave may look good on the outside, it could be grooved on the inside where it's supposed to be smooth. But just be careful when you feel it, because it could be hot to the touch. Once you have determined that you need to change the belt, always loosen the motor, bring it forward, and lay the belt on, and then tighten it back up. Never try to roll the belt on without loosening it first, because then you take a chance of getting your fingers caught between the belt and the sheave. Once you've installed your belt, you must line up the sheaves. You can use almost anything to line up a sheaves as long as it's got a straight edge. A piece of wood, a piece of metal, angle iron, anything like that, and you just lay it up against the sheaves, make sure they're lined up. Next, we're going to talk about belt tension. This is probably the most important part of the procedure, and the reason why is if the belt is too loose, it will damage your belt and your sheaves. However, if it's too tight, it will damage the bearings in your motor or in your pump or fan or whatever it is that you're driving. Now I'd like to talk about the tools that you would use to check the tension of a belt. Now you can get away with just a straight edge and a tape measure, but I highly recommend that you use the tension tool. The first thing we need to do when we tension a belt is we need to find the span. Now the span is the center line of the motor shaft to the center line of the pump shaft. Here we have 13 inches. So you take, for each inch of span, it would be 1/64 of an inch of deflection. That would be 13/64 deflection. An easier way to do it is by using the tension tool. And here we have the tensioning tool. Now the tensioning tool has two O-rings. One O-ring for the inches of span and the other one for the pounds of deflection. Now, I have set this O-ring just above the 10 mark because it goes up in increments of 10. So I'm just going just above the 10 for the 13 inches of span. Next, we're going to show how to take a reading with the tensioning tool. First thing you do is you lay the straight edge along the belt for a baseline. Now to get the reading, you've got your straight edge for your baseline, and you put the tensioning tool with the flat part on the belt, about halfway between the span. Then you press down on the tool until the bottom O-ring reaches the bottom of your straight edge, and then you release. Release it, and you get your reading off of the second O-ring, and we got about 8 pounds. So we had 8 pounds on our tensioning tool. This is a chart that actually comes with the tool. It comes inside. I've got a bigger one just so that we can read it. Okay, so I got 8 pounds on my tension tool. Now, we need to get some information to find out where we're at with this tension. First thing we need to know is our cross section. This is a B51, so I know that falls with the BBX. I've got that marked on the chart right here. The next thing I need to know is the smallest sheave diameter. I know that my smallest sheave diameter is 5 inches. I've got that underlined right here, between 4.4 and 5.6. The next piece of information I need to know is the RPM range. That can be found on the motor data plate on the side of the motor. My RPMs is 1745. That falls between the range of 860 and 2500, which I have underlined on the chart. And this is a newly installed belt, so I would skip over the used belt column and go straight to the new belt column. It says I should have 7.9 pounds of deflection. I have 8, so I know that this belt is properly tensioned. This concludes our belt tensioning video. If you have any questions, you can always reach out to me or contact your zone leader. Thank you.